In the previous video, we saw that functions, especially device functions, can significantly reduce code repetition. However, even with functions, there may still be situations where code is repeated. When we define a function, we must specify the types of the arguments and return values. For example, implementing a function that compares two integers and returns the larger one is straightforward. However, if we need to compare two single precision numbers and return the larger one, we would have to write exactly the same code again for another function, with the only difference being the input and output value types. To address this program, we can use templates. Template implementation in heap allows to write a generic function that can work with different data types without having to know the specific data type ahead of time. And it is a concept borrowed from C++ language. A template is defined by prefixing the code with the keyword template followed by angle brackets. The data type that the code works with is specified as a parameter within the angle brackets. Here is an example of a simple template function for vector addition implemented in heap. The vector add function is a generic function that can operate on any data type T that supports the addition computation. It takes 4 arguments, similar to the vector add kernel used in our previous video on vector addition implementation in heap. Essentially, this vector add function launches the kernel and can be called for different types by specifying the type parameter T. For each type that the function needs to support, the compiler generates a version of the binary code so that any type that supports the plus operator can be executed using this kernel. Heap allows templates to be applied to global, device, and host functions. In summary, properly utilizing templates can make our program more powerful by supporting more data types and reducing code complexity. In the next video, we will discuss the basics of structs in heap and their applications.